we were doing yesterday, if I told you to write x to the 3/5 with a radical, what would you write? So 5th root of x cubed. And the cube can be inside the radical or outside the radical. Both are equivalent. So as long as you have one of those, it's fine. All right. If I asked you to go the other way, so if I said the 7th root of y to the 10th, exponential form just means with an exponent, so that would be what? Y to the 10 seconds. So we have to be able to go back and forth. Both notations have their benefits. So let's start reducing some radicals. If I ask you to simplify the square root of -7 squared, you have to be a little bit careful because a square root and a square cancel each other, but the answer is not -7. If I did my exponent, -7 squared is what?
49.
And the square root of 49 is 7. So the number that comes out of the square root is positive. Okay. If I asked you to do the cube root of 64, a to the 6th, b to the 15th. So what is the cube root of 64? So I need to know what number times itself 3 times equals 64. 4. All right, for my variables. All right, we can think, I have 6 A's, how many groups of 3 do we form? 2, it's just like dividing, 6 over 3. If I have 15 B's, how many groups of 3 do we form? 5. 15 divided by 3 is 5. If there's a negative on the outside, it just trails along. So my answer still has a negative. What is the 4th root of 625? Over. What is the 4th root of 81?
3.
So we get -5/3. Does everyone know how to do like cube roots, 4th roots on your calculators? 4th? Okay. If you hit 4, and then if you go to math, and it's just number 5 there. That will allow you to do any kind of root that you need to. Anyone else need calculator help? Shouldn't use a calculator, I guess. Just figure it out. All right. But we know, you guys have reduced radicals before, you know they don't always work out perfectly. So we need to be able to reduce them. Now, some calculators reduce them for you. Do you think on a test I would let you use a calculator that reduced it for you? No. I want to make sure you know how to do them. So make sure if you have one of the calculators that reduce, so like these actually do, but that's not going to be very helpful if you just type them all in on that and you don't know how to reduce them by hand. Okay? So make sure we understand the process. If I say the 4th root of 32, if you type that in the calculator, use the graphing ones, it's going to give you a decimal. Okay? It doesn't tell us what that is exactly. So we need a perfect 4th power that goes into here so we can break up the 32. Okay, so things to the fourth power. We think like 2 to the fourth is 16. 3 to the fourth is 81, which is already too big. Can we break 32 up into 16? Yeah, it's 16 times 2. So, the fourth root of 16 is 2. We worked that one out, so the radical disappears. But I cannot do the fourth root of 2, so that just stays. So my answer is 2 fourth root of 2. If I said the cube root of b squared over c to the 9th. A cube root is asking me how many groups of 3 I can form. We can think of this as the numerator and denominator separately. On the top, if I have 2 b's, is that enough to form a group of 3? No, so that b squared just stays under my cube root. On the bottom, if I have 9 c's, how many groups of 3 can we form? 3. Since it's 3 groups, the radical is gone from that term. So it's the cube root of b squared over c to the 3rd. I want you guys to try a couple. How am I going to break up the 18? It's a square root, so I need a perfect square. So think about squares. 2 squared is 4. Can you do 18 divided by 4? No. 3 squared is 9. Can we do 18 divided by 9? Yeah. So we're going to break that up into a 9 and a 2. The negative on the outside stays. The square root of 9 is 3. And we can't do the square root of 2, so it stays under the radical. If I have 5 x's, how many groups of 2 can we form? 2. So x squared comes out, but how many are left over? 1. Okay, so think about 5 x's. Here's a group and here's a group, so that's the x squared out in front. There was 1 x left, so it stays under my square root. If I have 7 y's, how many groups of 2 can we form? 3. And then that would leave us with 1 y left over. So negative 3 x squared y to the 3rd times the square root of 2xy. All right, D. We just go variable by variable here. So if I have 7 a's, how many groups of 4 can we form? 1 group of 4, and then that would leave us with 3 a's under the radical. Okay, if I have 10 b's, how many groups of 4 can we make? 2. That takes up 8 of my b's, so there are 2 remaining under my radical. If I have 8 c's, how many groups of 4? 2, and there are none left over, so that radical is gone from the denominator. Do you guys remember doing this before? I'm going to give you a few more to try. So reduce these radicals for me. So cube root of 24. I need a perfect cube that goes into 24 evenly. What would that be? 8. So we can break 24 up into 8 and 3. So the cube root of 8 is 2, so a 2 comes out. Can't do the cube root of 3, so it stays under the radical. If we have 5 a's, how many groups of 3 can be formed? 1, with 2 left over, so the 8 squared stays under. If I have 10 b's, how many groups of 3? And that would leave us with 1 b remaining in the radical. All right. On B, so the fourth root of 48. So something we can do the fourth power, or the fourth root of, that goes into 48. What would that be? 16 times 3. So fourth root of 16 is 2. That comes out. We can't do the fourth root of 3, so it stays underneath. If we have 9 x's, we can make how many groups of 4? And that leaves us with 1 left over. Okay, on the bottom, if we have 12 y's, 12 divided by 4 is 3, that goes evenly, so there's none left under the radical, it's just a y cubed. So 2x squared over the fourth root times the fourth root of 3x over y cubed. C. So start with our 50, the square root of 50, a perfect square that would go into 50. 25 times 2, so the square root of 25 is 5. Can't do the square root of 2, so it stays. If I only have one a, can we do the square root? Can we make a group of 2? No, so that just stays underneath. 5 b's, so we can make 2 groups of 2 with 1 left under the radical. On the bottom, the square root of 9 is 3. If I have 20 c's, how many groups of 2 can we make? 10. And since we divided them into groups already, there are none left over, that radical is gone. What questions do you guys have on those? Let's use our radicals to simplify some expressions. So if I told you to do the square root of the cube root of 27, we start on the inside. Can you do the cube root of 27? 3. Okay, we only did the cube root, so my outside radical stays. Can we do the square root of 3? No. Do any perfect squares go into it? No. So that's our answer, square root of 3. Just, if you have multiple radicals, you start on the inside, work your way out. If I said the square root of 6a times the square root of 7ab. Okay, if I just start trying to simplify, I can't do the square root of 6. It's not divisible by any perfect squares. I only have 1a. I can't break it down. Same thing over here. I can't break down 7. I don't have enough a's or b's. What we can do is multiply these radicals together. Since both things are under a radical, when you multiply, the square root stays, and you just multiply the things underneath. So 6 times 7 is 42. A times A would give us a squared, and we have our b. So the square root of 42, a squared b. Now, do any perfect squares go into 42? No, it can be 1 and 42, 2 and 21, 3 and 14. 4 doesn't work, so it's not going to break down into any perfect squares. So we just keep the 42 under the radical. If I have 2 a's, how many groups of 2 can be formed? 1. So 1a comes out. There were none left over, and we only have 1b, so it's not enough to make a group, so it just stays. So it's a square root of 42b. what do I have to do in this problem? What? So when I multiply these, if you're multiplying with radicals, the numbers outside our radical get multiplied together. So the 3 and the 2 give me a 6. And then the numbers under the radical get multiplied together. So 5 and 5 is 25. Plus 3 radical 5 times 1 is just 3 radical 5. Inside. So these 2's are both outside the radical, so we multiply those. So we get a 4. The square root of 5 just trails along. The last term is negative 2 times 1 is negative 2. So now we need to combine any like terms and reduce what we can. 6 square root of 25. What is the square root of 25? So that just means 6 times 5. When you're adding radicals, you add the coefficients. So 3 plus negative 4 is negative 1. The radical doesn't change. So just negative radical 5 or negative 1 radical 5. And then we have the minus 2 on the end. Right, so 6 times 5 is 30. Minus the square root of 5 minus 2. Combine like terms, 30 minus 2 is 28. 28 minus the square root of 5. Questions on multiplying with those?
How do we get the radical 5?
In like the final answer or
The second one. Did
right.
we just take it out of those two?
yes, I just actually added the coefficients. So 3 plus negative 4 gave me negative 1. Any other questions? Second question. So we can only add or subtract when we have like terms. With radicals, like terms mean the same thing under our radical. So up here, those radical 5s were like terms. But down here, I have a cube root of 16, cube root of 54, cube root of 2. They are all different, so I don't have any like terms yet. So we have to reduce them. Okay, my 5 is just staying for a moment. 16, do any perfect cubes go into 16? 8, 16 is 8 and 2. Okay, I'm just going to bring down my coefficients for a minute. So 54, what can I break it into? So if you need to, make yourself a list. Cubes, 2 to the third is 8. 3 to the third is 27. 4 to the third is 64. 5 to the third is 125. Do any of those divide 54? 27 and 2. Minus 4. Can you break down a cube root of 2? No, so that just stays. Alright, so here we have a 5 times the cube root of 8. That is a perfect cube, that is a 2, so it comes out of the radical. And my radical 2 just stays. Here we have 3 times. What is the cube root of 27? 3. So we get 10 cube root of 2 plus 9 cube root of 2 minus 4 cube root of 2. Now they're all cube root of 2, so we can combine the coefficients. So 10 plus 9 minus 4. And the cube root of 2 just stays. So if I'm asking you to add or subtract, reduce your radicals first, and then you can add like terms. What questions do you guys have? I'm going to stop here today. So first off, if your Math Excel isn't done and you had questions, now is a great time to ask those. Today, there is a handout posted on Google Classroom. You can do most of it. What we have not talked about yet is rationalizing denominators, so getting a radical off the bottom of a fraction. So tomorrow we're going to do that and also a little bit of review.